part 2 of multidimensional arrays. Let's jump right in, but I have a question. Are we ready to maybe even answer a question on this to solve a problem? We ended last time by looping over the rows, summing all of the elements in a given row, summing all the elements in a given column. Are we ready to now go solve a slightly more meaningful problem? Maybe you're thinking, yeah, let's bring it. I'm just having fun with the slide deck here, the stream deck. So if so, here we go. Write a program to grade a multiple choice exam for students. Assume there's 8 students. Each student has answered 10 questions, right? The answers are going to be stored in a 2-dimensional array. Here's a depiction of that. So we have 8 students from student at index 0 to the student at index 7. And here are the answers for the students. For example, the first student at index 0, their answers for the 10 questions from index 0 to 9, those 10 questions, here's the answers for student 0. So each row represents the 10 answers for one specific student, and we need to write a program to grade that, to basically compare their answers to an answer key and then score each of those exams for the students. Here's the answer key. So question 0 should be a D, and we notice that student at index 0, for question 0, they did not put a D, they put an A. They got question 1 right? Because 1 is a B and they put B. They got 2 wrong because they put A and it should be a D. They got 3 and 4 correct, as well as 5, because they put C, C, and D, and it was C, C, and D, right? Hope we see what we want to do. We want to compare these values to the key. That's all for student 0. Then when we're done with that, we're going to print the score for student 0. Then we want to compare these values to the key, and so on. So the overall idea, we have this key, it's going to be stored inside a 1-dimensional array, and we're really going to need to loop over all of these 8 students, and then for each student, we need to loop over their answers, compare their answers to the key, keep track of all of that, and then print out their scores. So what I've done is I've started this. Let me zoom in, because I didn't want to sit here and type these this entire 2-dimensional array of their answers. That'd be a disaster to type that live. So we have here our main. In our main, we made the answers, we made the answer key, and now we want to call this method grade exam. So here we have public static void grade exam. In this method grade exam, what are we sending to it? Notice there's 2 parameters. The first parameter is answers, which is a 2-dimensional array of characters. So it's going to be char bracket bracket answers. And the second parameter is key, which is a 1-dimensional array of characters. Here we have key, and it's a 1-dimensional array. So what do we want to do? We need to loop over all students. So loop over all rows of the 2D array of answers. Loop over all rows. So for FOR tab, I'm going to type in, I'll rename this for row for now to be similar to the last video. We're going to loop from row index 0 to the last row, which is where? At answers.length, right? We covered that. That is going to be answers.length. That's going to be the number of rows or the number of students. And you know what? Let's, instead of calling this row, I've decided, let's call this student. It feels better. Student index 0, student index 1, and so on. So now what we want to do is we need to have a score. Let me declare score up here. Or we can correct count. Well, let me come back and even see what we should print. We have an output, so we need to print a percentage, which since it's 10 questions, they're correct every one that they get correct. We can just increment by 10 and just print the percentage afterwards. It makes it kind of easy. So here we'll do a int declare score variable. So int score, and we'll even print it with a percentage. Why not? We'll do it properly. Let's count correct. Count correct. And each time they get one correct, we're going to count it. So here, I do know I need to go ahead and reset this for each student, but I'll explain that afterwards. So now we need to do what? For a given student, loop over their answers. Loop over the answers for student at index I, or student at index student. This should be not students, it should be student. Let me rename this student. Loop over the answers for the student at index I, but again, I didn't call this I called it index student. Okay, so we do a for loop. We're now going to be looping over what? All of the answers in a given row. So we need to loop over the length of that row. The length of that row is going to be answers at index 0.length. And because it is a rectangular array, it's not a ragged array where every row has different lengths. It's a rectangular array, so therefore I can just say answers at index 0.length. But if you wanted to be more general, you could say answers at index student.length, where this index student will change. But I'll keep it at just answers at index 0.length. What do we want to do here? We just want to compare the answer of the student to the key at the given index. So what we want to check is if answers at index student at index, bear with me, I'll put I here for now. I might want to change that. If that equals the key at index I. And let's explain this. If it does, we're going to increment count correct, which means up here we could have initialized it, but I'm going to change that. But if we found a correct answer, we need to increment count correct. So look at how we've done this. Remember, now we're doing an inner loop to loop over all of the answers within both the answer key or within the row of a given student. So if we're at this student right here, we need to loop over all of those answers. There's 10 of them. And we need to compare it to these 10 values of the key. So I is my looping variable, and I'm saying if answers for this particular student, let's say it's student 0. If the answers for student 0 at index, and what is this here? This is the index of the column, which is, let's say, at column index 2. Well, if that equals the key at index 2, increment count. And then if for student 0, if their answer 3 equals the key at 3, increment count. All the way up to if their answer at index 9, which is for the 10th question, if that equals the key at index 9, increment count. So hopefully we understand that when we put in those specific numbers. So now back to the more general way of coding it, we're going to say answers at index student at index I. If it equals key of I, we found a correct answer, increment the count, and then as soon as we're done incrementing that count, and as soon as we're done looping over one student, so after looping over the answers for a single student, print their score. And we want to print the grade for student 1 colon. So here we want to print, formatted printing, grade for student %D colon %, let's call it, I'm going to do floating point, but I'm going to say 0.0, no digits after the decimal, 0.0f, new line. And actually we want to print a percentage, which is funky. If we haven't seen that, we do this. This % says the next symbol is important, such as a D right here or an F right here. But if you put %, that says, oh, it's not important, just print a % for us. Okay, comma. What's the first placeholder I'm printing? The student number. We're looping over the students from 0 to the last student, but we want to print from 1 through 8. So I'm just going to put here student +1. And then what am I going to print right here? Here I need to print their score, which is really, I'm counting the number of correct. So if they got 3 correct, that's a 30%. I could have just said correct plus equals 10 each time, so I don't have to do any special math, but then it won't work for other numbers of questions being asked. So let's do this correctly. So here, if they've scored 3 correct, which is 30%, how do we get that? Well, we're going to take their count correct. We're going to divide it by using integer division, using floating point division, 10.0, and that will give us 3 divided by 10. That's going to give us 0.3. We now want to multiply that times 100 to get 30.0, and we will not print that decimal. What am I missing here? I have that curly bracket. Oh, I didn't put my times. That is a super, super big brain to not put the times. That's fantastic. So now that's working. So let's follow this. Loop over all of these students. For each student, loop over their answers and compare their answer at a given index, so their answer at index 6, for example, compare it to the key at index 6. If those answers are the same, increment the count correct, and then print. Now, because we have to, watch what happens when I print this. You're going to see the scores are going to get crazy. When I run this, the first person's score is going to be accurate, but everyone else is going to be wrong. This student got a 70, and then you notice, wait, why are their scores increasing so much? Well, it's because we're not resetting. Reset the count correct variable for the next student, right? So here, count correct equals 0. We need to reset that to 0 at every iteration, so we're starting a brand new count. And so therefore, there's no need to actually initialize it above to 0. So now when we run this code, we're getting exactly as we expected. 70, 60, 50, 40, 70, 60, 50, 40, 80, 70, 100, 70. Perfect. So what did we do? We called this grade exam method. That grade exam method did what we just coded, and hopefully this is a good simplistic example of how to use a two-dimensional array of these values. Kind of cool that we compared it, one of those dimensions we compared to a one-dimensional array, this key, at every iteration, keeping track of the count. All right, multi-dimensional arrays. We've seen two-dimensional arrays. We just saw an example, but Java, as well as other languages, you can in fact create n-dimensional arrays. And that's going to make some of you absolutely 100% not only cry, want to give up. No, we're not going to cover too much with this, but you should be aware that it's something you can do, and there are meaningful use cases of this. The following, I'm going to give an example. It may not be the best use case, but there's a lot of meaningful use cases depending on your discipline and what you're really coding in. So here we say, using that same example, we say, suppose you have a class of 6 students. Each student has 5 exam grades. So it sounds like a two-dimensional array, where we have rows are the students and the columns are the 5 exam grades. But now imagine that each exam grade is really 2 portions. The first portion is the multiple choice component, but the second component of the exam grade is an essay section, right? So again, we had the 5 rows for the 5 students, or we have 6 students, and each student has those 5 exam grades, but each exam grade is really separated into a multiple choice exam as well as an essay section. So that's going to be a 3-dimensional array, as you see here. So we can declare this array called scores, where we have 6 students. Each student has 5 exams, and each of those exams has 2 parts, the multiple choice and the essay. And so you can really see this the way it's depicted here. We have the 5 rows for the 5 students, and each of the student you can see has 5 pairs of curly brackets for their 5 exams. And within each of those curly brackets, we have 2 scores for this 3rd dimension, the multiple choice score, finally followed by the essay score. So if we look down here, it says that 0, 1, 0, this is student at row 0, And this 1 right here refers to their first exam, so it's referring to this student's exam right here, or this exam. And this 0 refers to their multiple choice result, 9, of their second exam, which is at index 1. Hopefully that's clear. Multidimensional arrays, helpful, but absolutely more of like a moment where it's like, oh no, and we get a little bit sad. But no need to be sad, because now we're going to have a super happy moment when we're looking at array lists. What are array lists? Array lists are most analogous to a Python list. So if you recall, when we started this journey with arrays, we said, hey, we're going to jump in. Java and Python, they both have arrays. They both have arrays. They both have lists. But Python, we normally cover lists first because, frankly, they're easier. It's more approachable, right, for a new student, a new learner. But now that we already know lists for Java, we'll often start right with arrays, because now that we're more mature developers, we can approach arrays, right? We can understand them. Hopefully we have a good understanding of both 1D and 2D arrays. And with that in mind, now we'll introduce array lists, which are super fun and super easy because it's like a Python list. Recall the limitations of an array was that they're fixed size. You can't change the size of the array. The elements have to be of the exact same type. You have an array of doubles, that's all it can be. You have an array of strings, that's all it can be. You can't save different data types into an array. And then finally, as the developer, you have to be worried about saving things at particular indices, maybe shifting things over if need be when you're adding an element at a particular index or removing an element from a particular index. So you have to be very careful and take care of all of that yourself. Those are negatives. The value of using a traditional array is you have full control, and you can feel it explicitly when you're making those for loops, when you're shifting things. You have full control, and in a way it feels nice, but array lists make your job super easy. So Java gives us this ArrayList class, which again is most analogous to a list in Python. Array lists can grow and shrink. And I say at least they appear to grow and shrink. Because when we really learn what's under the hood, you're like, hey, wait, no, that didn't really grow and shrink. But for our purposes, let us assume array lists can grow and shrink. You can potentially add an unlimited number of values to an array list. Also, an array list can in fact contain elements of different type. So let's make our first array list. An array list is an object. It's created from the ArrayList class. In the same way that a scanner is created from the scanner class, how do we make objects from a class? We have to use that keyword new. So here's how you make a new array list, and you can save some values into it. Notice I have the variable stuff. Let's look at the right side of the assignment, just like scanner, right? We would say equals new scanner parentheses because we're calling a method, and we send over system.in. It feels like we're calling a method. It's really called a constructor. We're coming to that in just a bit. But we're making this new scanner object is how we would normally see that keyword new. Well, in that same vein, here we're making a new ArrayList object. And we have created that object, and we save an address of that object into the variable stuff. What is that variable stuff? It is of data type ArrayList. And now see, I can just say stuff.add. I can add the string Florida. Stuff.add 8, add the number 8. Stuff.add 9.617. I can add a double to that as well. So each item is merely appended to the list, which means added at the end of the list. So stuff.add Florida is added at index 0. Then we add 8 at index 1, and this 9.617 is added at index 2. And notice that we're adding elements of different types. That's allowed with array lists. What comes next is there's many methods in this ArrayList class. The common ones are add, get, we're getting an element at a particular index. We have the size method, which will give us the size of our array list. Contains will tell us true or false whether or not our array list contains a particular value. and then remove, which will remove an element from our list for us. There are many other methods. There are some shown in here, and you can also simply go to a browser, type in Java ArrayList, and go to the Java documentation, the Java doc page, and simply look at all of those methods that are available to you. So let's take a closer look at this get method. So here, if we've added those things to this array list called stuff, I can now get the values at those particular indices. Get 0, stuff.get0 will get the word Florida. It'll get the value at index 0. Stuff.get1 will get the value at index 1. It'll print 8. And then stuff.2 will print the value 9.617. So instead of the bracket index, now we're using .get. .size will tell us the number of elements inside this array list. Kind of like array.length, here we have a .size method. So we have the same things we've added to that array, but now instead of getting them one at a time and explicitly typing the index we want to get, here notice I use a loop. I say let's loop from I equals 0 to I less than stuff.size. And what do we want to print at every iteration of the loop? We print stuff.get at index I. So at index 0, we're going to print Florida. We get in the value at index 1, which is an 8, and then we get what's in the stuff array list at index 2, and we print that as well. So what we've seen thus far is this array list that we can add all kinds of elements to it, elements of different types. That's unique. There might be use cases for that. And the value of this is an array list is actually a generic type. It's known as a generic class with a generic type E. And on those last examples, we were able to add all of these different types of data to our array list. We can also replace that generic type E with a concrete type, as we see on these two examples below. And this looks really weird the first time you see it. The arrow, pair of arrows, if you will, where we have ArrayList string cities equals new ArrayList string. Old syntax used to be that you would list out the data type here on the left when you're declaring this variable cities. What this is really saying is, hey Java, I got this new array list of type string, it's called cities. On the right side, of course, where our eyes look first, we're saying, yo Java, make me a new array list of type string, take the address of that new array list, save it into the variable cities. By the way, what is cities? It's an array list of type string. So the newer way of typing that exact same line of code is you don't actually specify here on the right side what the data type is, because it's redundant since it's already identified on the left when you declare that variable. So the Java array list, it can only store objects. Super important to know. You cannot store primitives inside an array list. And you might be thinking, what are you talking about? Didn't we just see this example? Didn't we see that I added the integer 8 to the array list, the integer, the double 9.617? What are you talking about? Those are primitives. They are. So it's a good observation if you recognize that, if you caught that. It appears as though primitives can be stored inside an array list. However, what Java does under the hood is it boxes up this integer or this int value 8, and it boxes it up into its associated object. What do I mean by that? The primitive int is boxed up into an integer object, and it's actually saved into an integer object. This double 9.617 is boxed up and it's saved into an actual double object with a capital D. So instead of being a primitive double, it's boxed up and it's saved inside this double with a capital D object, thereby allowing ArrayLists to store those values, because ArrayLists can only store objects. So here finally we have where I've created an array list of both integers as well as doubles. This variable number, what is numbers? It's an array list of integers. And what is GPA values? It's an array list of doubles. Here is just a slide showing some differences between an array and an array list. So if I want to create an array, as you know, I could say string bracket A equals new string 10. Here, array list of string, maybe I call it list equals new array list. Accessing an element with an array, square brackets. Accessing an element in an array list, dot get. If you want to update an element in an array, we just use the square brackets. Say, hey, you know what, let's save London over into that index. Or we could say list.set at that index, let's set London. The length of an array is with the dot length operator of arrays, whereas we would have to use dot size method on an array list. Those are the comparisons, and there's other things that we've seen here as well, adding and removing, and even clear, which clears out and removes all items from your array list. This final slide before we do two small programs is just to show you how you can create an array list from an array of objects. So here if we have an array of strings, red, green, blue, right? The first line we should understand. How can we convert that into an array list of strings? Well, we can say new array list, and then in parentheses, I can say arrays dot as list. This is part of that arrays class, right? We saw arrays dot, what was it? Binary search, arrays dot clone, arrays dot, what else did we see? We saw a variety of methods within the arrays class. Well, here's another method, arrays dot as list, and we send over the address to this array, and it then converts it to an array list, which gets saved into lists. We can also create an array of objects from an array list. So I say, assume we have an empty list called list1. I can then, given an array, I can say string array1 equals new string list.size. So I have to declare the array first of the exact same size of the list that we're going to create from, and then I can just say list.toArray of array1. Not that big of a deal, just showing how you can convert between the two. What really is most important is to use the next few minutes on solving some problems. So the first program we want to look at is we want to generate an array list. Write a method called generateList that creates a new array list of integer data type and adds to this list 20 random values between 1 and 50 inclusive. I say that you should send a seed to this method that we will use to seed our random number generator, and you'll see the purpose of that as we solve problem 3. But we want to send a seed over to this method. It'll have one parameter, the seed, and we'll use that seed to seed our generator when we generate these random numbers. Your method should then return a reference to this newly created array list of integer values. So here we go. The problem solving phase. Make a new array list of integers inside the method. Let's go to make a method. I have this open already, ArrayList demo, and we want to make this method. What is the method called? Public static, and we'll look at the return type in a minute. Return type, return dash type. It doesn't like me typing this obviously because that's not real code. And this is called generate list. And I said that we're going to send over to this method some seed or seed value. We're going to send to it the seed that we're going to use to generate our random numbers. So let's start by actually making a random number. So a random number generator. Random RNG equals new random, and let's set the seed. RNG.setSeed to this seed value. Done. What do we do next? Make a new array list of type integer inside the method. Cool. This might be the first time we're typing this for some of us. Array list, left arrow, integer, right arrow, space. And what do we want to call this? What are we doing? We're creating a new list of just numbers. Let's call it numbers. Equals new array list. And here you put this left and right arrow, and then you have to put a parenthesis, semicolon. It takes a while to get used to coding that. I agree. Full disclosure. It takes a while. But once you get used to it, you'll be good. So make this new array list of integer values, done. Loop 20 times, let's knock that out, FOR 20, loop 20 times. Each time generating a new random number between 1 and 50. So we can do that. Let's come up here, type int random number. I want to declare that above so I don't redeclare. I don't want to type here random number and redeclare that particular variable 20 times. So I declare it above. Random number equals what? rng.nextInt. What did it say? From 1 to 50. A random value between 1 and 50 inclusive. So from 1 to 51 right here. And then what do? We need to add this value to the array list. No problem. So ArrayList is numbers.add random number. Done. I could have, of course, done this in one step. I could have just said add that new random number. But I think it feels better to maybe do it in two steps. You can see what's going on. And then finally, return the address of this newly created array list of integer values. Simple, return numbers. So now that we see that, let's come look at the data type. What do we put for this data type up here? Return numbers. Well, what are we returning? Is it an integer? No. Is it a double? No. What is it? It's an array list that we're returning. But in particular, you should specify what's saved in that array list. Notice it's not giving me an error, but it's better when you put, I'm returning an array list of integer. And you'll see more, these nuances, why that's important to specify specifically or explicitly what is saved inside that array list within the return type. So public static, the return type is, I'm returning an address to an array list of integer values. Cool, that's the code. Here's something similar, not commented. And let me zoom out just a little bit so we can see the full code. This is what we have, similar to what we have here, that I simply called it values or vals. All right, what's next? Write a method called common values that receives two parameters, each an array list of integers. Your method should make a new array list, a third array list, and this array list should only contain the values that are found in both of the other lists. This method should then finally return a reference to this new array list. So I'll explain that more as I go through typing this and coding it. Public, static, and what is this one called? Common values. This method receives two parameters, each one an array list of integers. So here's how you have to type this. Array list of integer. Let's call this list 1. Array list of integer list 2. And what is the return type? It said that you should return a reference to this newly created array list. So it's going to be the exact same return type that we had above, array list of integer. So what do we need to do with this method? This method, it's receiving two lists. Those lists might have common numbers between them. So for example, here's list 1, here's list 2. Imagine there's some common values between them. In fact, there are. They both have the number 2, the number 4, and the number 7. We want to create a third list that will contain only those three numbers that are common between them. So the first thing we're going to do in here is make an array list. So array list, integer, let's call it list 3 equals new array list. So you get quicker at typing it once you've done it a dozen times. We make that new array list. So now what do we need to do? We need to find the values that are common between list 1 and list 2. How do we do that? Well, the algorithm here, it says loop over each value of list 1. Let's check that out. Let's convert that right to code. Loop over each value in list 1. So we're going to loop to list1.size. And what do we want to do? We want to do what? If the value, each of those values, look at a certain value of list 1. If it's found in list 2, we'll add it to list 3. Let's make that as a comment. If the value of, I'm going to call it, if the value at index I of list 1 is found inside list 2, add it to list 3. So how do we do that? We're checking if something is inside list 2. Well, we can say if list 2 dot contains, if it contains something, we'll look at the something in a moment. What do we want to do? If it contains something, we want to say list 3 dot add something. Well, what do we check here if it contains something? What are we checking if list 2 contains? If list 2 contains the value of list 1 at a given index. So list 1 dot get will get us a value at a particular index. And we're looping from I equals 0 all the way over the size, the number of elements in this list. So if list 1 dot get index I, that will get us the value at index I of this list. If that value is inside list 2, if list 2 contains that value, add it to list 3. Done. And what do? Return list 3. There's your method. Common values. We loop over the entire list 1. If list 2 dot contains, for each of those values in list 1, we check if it's contained in list 2. If it is, we have a match. Add it to list 3. Done. And then return list 3. That is the method. And here's what I'm showing on this particular slide. It looks to be pretty similar, even commented similarly. What remains is, now how can we check this in main, right? So let's make some array list. Array list integer, let's call it L1 equals, and what do we want to do? Let's create an array list. Let's call this method generate list, and let's send over to it a seed value. Let's call the seed, I don't know, 67. And let's do another one, array list of integer, L2 equals generate list, and let's send over for this seed 98. If you use the same seed values, and if you, within the method, made a new random and you set the seed with that seed value that we're sending over, that's why we're doing this, you'll get the same generated numbers. So now we need to do what? We want to call this common values method, and we want to send over L1 and L2, and this method is going to do what? It's going to see which values are common. It's going to add it to this list 3 that we created, and it's going to return an address of this list 3, which means what? We should catch that address when it's returned to us. So here I need to say array list of integer, I'll call it result, equals, and I've caught that result. So finally, let's just print this out to see if we got what we're expecting. Let's print out L1, and you can actually just print out a list like this if you just want to see quick and dirty what's inside it. L2, and let's print out L3. Oh, no, it's not L3. I called it result. And let's run this code. So let's see. Here's the two lists. Apparently 4 values are common between them. We have a 44. Where's a 44? Right here is a 44. And does this one have a 44? In fact, it does right here. But it's hard to read this way because it's not sorted. So I'll leave you with one other thing, and that is, how do we sort an array list? We've seen how to sort an array. You would say arrays.sort, and then you would send over the name of your array, name of array, right? Well, this is not an array, this is an array list. So how do you sort an array list? Easy. You use collections.sort. So simple as this, collections.sort, and then we send over L1, and we're going to do that exact same thing twice more. Let's sort L1, let's sort L2, and let's also sort result. And when I run this now, it'll be easier. Instead of having this unsorted, this should all be sorted. So now, does it have the 11? Sure it does, right here and right here. Does it have a 21? Indeed it does, right here and right here. A 37 is found here and here, and then of course they both have a 44. That's a good problem. A lot is involved in this code. What do we have? Let me zoom out. What's really going on in this code? We're creating multiple array lists right here. We're generating this list. We're coming to this method up here. We're creating a new list. We're generating numbers, adding it to that list. We are returning an address of that list because the list is on the heap as well. We're returning an address of that list, and we're saving it into L1, which we declared as an array list of type integer. Rinse and repeat. We're doing that again calling that generate list method, sent over the seed, generated a new list of array list type integer, added the numbers to it, returned that address, saved it right here. Then we call our common values method, which loops over all the values in list 1. For each one, checks if it's contained in list 2. If it is, we add it to list 3 that we created right here. And then finally, when we're done, we return an address of this newly created list 3, and we save it right here into result. We sort them, we print them. But a great example because the parameters is just different. The first time you have to use array lists as parameters here, and we're typing array list, these arrows, integer, it's funky, it's weird. But once you do it a few times, you'll get comfortable with it. And to be very honest, look, that add, get, remove, you're going to see obviously so much better than having to deal with the square brackets of an array and having to shift everything yourself, which is something we've not even had to deal with yet, but it can be a big, big headache. Just I'll leave you with this. Imagine you have, gosh, I don't know, 100,000 items in an array, and you delete the value at index 847. Well, you can't leave that index as a whole empty. What happens is you have to shift all of the items to the right of it one spot to the left, or at least you should. That's an expensive operation, like costly. It's a lot of shifting involved just to delete one element. But it's a lot of coding too. You got to do a for loop to shift everything to the right, one spot over to the left. What a disaster. Array lists do that for you. We are done under 45 minutes. Let's go. As always, reach out if you have any questions. Leave a comment. It's been a blast. Take care.